Welcome back to another issue of A Current Affair. Today we talk about Sustainable Development Goal 15, Life on Land. SDG 15 is broken up into more specific targets to enhance the achievability of the goal. Target 15.3 aims to combat desertification and restore degraded land. The protection and correct management of land plays an important role in society, as land in poor condition is unable to support agricultural practices, consequently reducing crop yield, threatening food security, and impacting the lives and incomes of agricultural regions. Furthermore, SDG 15 is an essential goal as forests provide habitats to millions of animal and plant species, mitigate climate change by absorbing harmful greenhouse gases, provide clean water, and prevent soil erosion. Now passing over to molecular biologist Gabby.
Thanks, Ava. SDG Target 15.3 displays a strong link to molecular biology as it provides the tools needed to reach the goal of combating desertification by 2030. Molecular biology techniques are used to study soil microbiomes, enhance soil health and fertility to restore degraded land. Studies can also be conducted to understand and identify genetic markers that are associated with resistance to soil degradation. Now over to Anna.
Thank you, Gabby. To track the progress of SDG 15, specifically Target 15.3, there are three key indicators: protected terrestrial areas, permanent deforestation, and imported deforestation. In 2023, Australia protected 57.3% of its terrestrial land, progressing from 33.5% in 2000. Since 2020, however, this remains stagnant. Permanent deforestation in Australia is sitting at 0.06 land coverage annually, a slight increase from the previous 3-year period, while globally, Europe and much of the world's northern regions have achieved the long-term objective rate of 0%. Imported deforestation improved to 11.2 metres squared per capita in 2022 from a value of 16.4 2 years prior, showing a steady progress towards a global 0% land coverage target and end of desertification by 2030.
Thanks, Anna. When considering SDG Target 15.3, microbial species can indeed help restore degraded land and soil. In fact, there is current research investigating the effects of microalgae species on soil regeneration, specifically to restore soil structure and fertility. It has been found that microalgae can restore soil structure by releasing exopolysaccharides and forming soil aggregates, which serve as protection from unfavourable conditions such as pH, temperature, and osmolarity. Further research into this field has suggested the fertilizing potential of microalgae as it contains phytohormones such as auxins, cytokinins, ABA, ethylene, and gibberellins, which serve as plant-promoting substances. Microbial consortia have several advantages over other species, such as resistance to environmental fluctuations, the ability to survive nutrient starvation periods by sharing metabolites, resistance to invasion by other species. However, when co-inoculated with bacteria, the two species exhibit mutualistic behaviour that enhance the positive effects listed previously by boosting their metabolism. The bacterium increases the supply of CO2 to the microalgae and decreases the O2 levels, thereby amplifying the rate of cellular respiration of microalgae, allowing it to grow and proliferate in soils and thus continue to provide nutrients and structural integrity. There is a strong link between molecular biology and the use of microalgae to restore degraded land. It contains exopolysaccharides, an essential carbohydrate that is predominantly found in microbial species. Microalgae can also release phytohormones, for example, auxin, which stimulates cell elongation in plants and is predominantly composed of various amino acids.
As mentioned previously, the eastern coast of Australia, specifically Queensland and New South Wales, is currently experiencing intense soil degradation. This is due to various reasons, including harsh farming practices, but the incorporation of fertilisers and pesticides contribute to the acidification and nutrient imbalance of the soil. The eastern coast also experiences intense rainfall patterns that enhance the surface runoff and soil erosion, as well as high temperatures that fasten the breakdown of soil minerals. The implication of a microalgae bacteria to restore degraded soils can help address these current issues along the eastern coast of Australia in various ways. It allows the soil to become stronger, therefore improving erosion, runoff, and reducing surface salt accumulation and water infiltration. The addition of the microalgae bacteria can help soils adapt to the harsh conditions of the eastern Australian coast, whilst also improving the overall quality of soil to help prevent degradation.
Continued research towards the ability of microalgae to restore degraded land and soil will lead to a promising future for life on land and terrestrial ecosystems. For example, the integration of the restorative properties of microalgae into other soil restoration techniques such as compost, mulch, and crop cover can optimise the soil structure, nutrients and water uptake, and composting processes, therefore enhancing the quality of soil and land for agricultural processes and terrestrial ecosystems.